October 3, 2025 marked a crucial moment in interstellar object research. The mysterious visitor known as 3I Atlas made its closest approach to Mars at just 28.50 million kilometers. Multiple spacecraft from NASA, ESA, China, and the UAE were positioned to capture what could be the highest resolution images and most detailed scientific data ever obtained of an object from another star system. But there's a complication. The US government shutdown means NASA's official website won't be updated during this period. ESA hasn't yet released their Mars Express and ExoMars images. We're in a waiting period, but we do have preliminary glimpses and fascinating new amateur observations. In this video, we'll examine what we expected the Mars orbiters to capture, the preliminary images that have surfaced, Harvard astronomer Avi Loeb's controversial 7 anomalies, and what mainstream planetary scientists say about all of this. This is based on the latest available data from peer-reviewed research, space agency statements, and Loeb's own published writings. Let's separate confirmed observations from speculation. Multiple space agencies coordinated observations of 3I Atlas during its Mars flyby. Here's what each mission was tasked with: ESA's Mars Express and ExoMars Trace Gas Orbiter. According to ESA's official statement from September, between 1 and 7 October, our Mars orbiters Mars Express and ExoMars Trace Gas Orbiter will observe the comet as it passes close to Mars, with the closest distance between the spacecraft and the comet being 30 million kilometers on the 3rd of October. ESA has likely obtained new imagery, but as of this recording, they haven't publicly released it yet. These images are expected to be among the most revealing looks at 3I Atlas will get. NASA's Mars Reconnaissance Orbiter. The high-rise camera aboard this orbiter was expected to provide images with 30 kilometers per pixel spatial resolution. To understand how significant this is, that's 20 times better resolution than Hubble's images captured in July, when 3I Atlas was 570 million kilometers away. However, there's a complication. Due to the US government shutdown, NASA officials have confirmed their website will not be updated, meaning any images obtained may take longer than normal to reach the public. Other missions. NASA's MAVEN spacecraft with its IUVS ultraviolet spectrograph, China's Tianwen-1 with its MORIC camera, and UAE's HOPE orbiter with its EXI and infrared/ultraviolet spectrometers were all positioned to contribute data. The Perseverance rover's possible detection. While we wait for official processed imagery, something interesting emerged. NASA's Perseverance rover, sitting in Jezero crater on Mars's surface, continued taking raw images throughout this period, and those are still being posted online despite the shutdown. Astrophotographer Simeon Schmaus stacked 20 raw images from Perseverance's Mastcam Z camera taken on October 1st. He reported finding what he calls a super faint smudge in the constellation Corona Borealis, very close to where 3I Atlas was expected to appear. Schmaus wrote on Blue Sky, "I think Perseverance may have spotted interstellar comet 3I Atlas last night from Mars. After stacking 20 images from Mastcam Z, I found a faint smudge of light in the constellation Corona Borealis close to the location where the comet was expected." This isn't scientific-grade confirmation. It's an amateur stacking of raw images, but it's an interesting public contribution to tracking this object. Harvard astronomer Avi Loeb mentioned this detection in a podcast interview with Brian Keating, describing it as an anecdotal but notable observation.
I analyzed the data from 4,000 observations of 3I Atlas over the past 4.5 months. So all of the data from 227 observatories on Earth shows no deviation from a trajectory shaped by gravity alone. And that means that despite the push on the object, it must be extremely massive to resist it. It doesn't care about it. And so I obtained a minimum mass of 33 billion tons.
Should see official, calibrated images from ESA and NASA in the coming days or weeks, once they're properly processed and verified. Before we get into controversial interpretations, Let's establish what peer-reviewed research has actually confirmed about 3I Atlas. Discovery and orbit. Discovered September 2024 by the Atlas Survey. It's on a retrograde orbit, moving opposite to the planet's direction around the Sun. NASA JPL orbital calculations confirm zero collision risk with Earth or any planet. Size and mass. Here's where it gets interesting. Research available on Archive estimates 3I Atlas's diameter at larger than 5 kilometers, potentially 5 to 10 kilometers based on brightness measurements. To put this in perspective, Oumuamua was roughly 400 meters long, about the size of a football field. The second interstellar comet, 2I Borisov, was similar in scale. 3I Atlas is estimated to be at least 1,000 times more massive than either of them. At 33 billion tons, if these estimates are accurate, 3I Atlas would be comparable in size to Manhattan Island. The extreme nickel-iron anomaly. Published research in astronomy and astrophysics reveals something genuinely puzzling. Using ESO's Very Large Telescope equipped with the UVES spectrograph, astronomers observed 3I Atlas at 6 different epochs as it approached the Sun. The findings: 3I Atlas is expelling massive amounts of nickel with almost no iron detected. The nickel-to-iron ratio is extraordinarily high, higher than any solar system comet and higher than 2I Borisov. The research paper states this explicitly. The presence of these metallic atoms at current distances from the Sun is extremely puzzling, as surface temperatures remain too low for sublimation of refractory minerals. The leading scientific explanation is sublimation of metal carbonyls, specifically nickel carbonyl NiCO4 and iron carbonyl FeCO5. These industrial chemicals can form naturally in cold, carbon-rich environments in space and sublimate at different temperatures, explaining why the ratio changes as the comet approaches the Sun. Chemical composition. Unlike most solar system comets, which are water ice dominated, 3I Atlas's coma contains primarily carbon dioxide. This suggests formation in a carbon-rich environment with different available materials than our solar system.
Non-gravitational acceleration. Like Oumuamua, 3I Atlas shows acceleration that can't be explained solely by solar gravity. According to compiled data from over 4,000 observations across 227 observatories worldwide, despite visible outgassing, 3I Atlas shows no deviation from a purely gravitational trajectory. This is unusual but not impossible. It could indicate the object is much more massive than typical comets, making outgassing effects proportionally smaller.
Harvard astronomer Avi Loeb has been the most vocal researcher arguing that 3I Atlas deserves serious investigation for possible artificial origins. It's crucial to understand that Loeb's interpretations are highly controversial, and most planetary scientists strongly disagree. However, his arguments are based on actual data, so let's examine them using his own words. In his Medium article published October 3rd, titled "A Recap of the Anomalies of 3I Atlas on the Day of its Closest Approach to Mars," Loeb writes, "In a new interview with Gadi Schwartz on NBC News, I divided the 7 anomalies of the third interstellar object 3I Atlas into 2 classes, those that could be alleviated with upcoming data and those that will remain puzzling forever. Anomalies that could be alleviated or explained away with upcoming data. 1. Size. Surprised, the diameter of 3I Atlas is larger than 5 kilometers, making its minimum mass of 33 billion tons larger by a factor of 1,000 to 1,000,000 than the mass of the second and first interstellar objects. 2. Jet. Contemplative. The Hubble image of 3I Atlas showed a forward jet of scattered sunlight, 10 times longer than it is wide, pointing towards the Sun. A weak tail showed up only at the end of August. 3. Unusual chemical composition. Puzzled. The plume of gas around 3I Atlas showed much more nickel than iron, as in industrial nickel alloys. Unlike solar system comets, the plume contained mostly carbon dioxide and not water. 4. Polarization. Intrigued. The light from 3I Atlas showed extreme negative polarization, anomalies that will remain puzzling forever. 5.
The trajectory of 3I Atlas is aligned with the ecliptic plane of planets around the Sun to within 5 degrees, 0.2% likelihood. 6. Astonished. The arrival time of 3I Atlas was optimized to pass near Mars, Venus, and Jupiter. 0.005% likelihood. 7. Wondering. The arrival direction of 3I Atlas is aligned to within 9 degrees with the WOW signal from August 15, 1977. 0.6% likelihood.
And also we know that the object came along a path that is aligned with the plane of the planets around the Sun. And that's highly unusual because the chance for that happening at random is 1 in 500. In addition, just a few days ago, I realized that back on August 15th, 1977, there was a very famous flare in the radio signal that was given the name the WOW signal because the observers that recorded it at Ohio State University was stunned at how powerful this signal was. And wrote "wow" in the document that records that signal, and so it's called the WOW signal from 1977. And I checked it. Turns out that it came from about the same direction in the sky as 3I Atlas, within 9 degrees. And the chance for a random alignment of the two directions of 9 degrees or so is 0.6%. So the question arises whether this WOW signal from 1977 was transmitted by 3I Atlas. We don't know, and there was no report on radio observations of 3I Atlas so far. So I'm encouraging radio astronomers around the world to check out whether there is any radio transmission from 3I Atlas. I calculated that back in 1977, the object was 600 times farther from us than the Sun is. And that was a large distance. And presumably, if it had transmitted that signal, it had quite a powerful transmitter, about a gigawatt, according to my calculations, which is comparable to the power output of a nuclear reactor that we have on Earth.
Most planetary scientists are highly skeptical of Loeb's artificial origin hypothesis. Here's why. On the statistical arguments, astronomers point out that when you're working with a sample size of only 3 objects, statistical arguments become much weaker. There are also selection effects. We're more likely to detect interstellar objects that pass close to planets because they're brighter and easier to spot. On the size issue, while 3I Atlas is indeed larger than Oumuamua and Borisov, larger interstellar objects should be rarer but not impossible. We've only detected 3. That's not enough to establish what's normal. On the chemical composition, the nickel to iron ratio is unusual, but the metal-carbonyl explanation is a known natural process. Carbon-rich environments in other star systems could produce these compounds. The WOW signal connection. This is perhaps Loeb's most attention-grabbing claim. Let's examine it. The WOW signal was detected August 15, 1977 by the Big Ear radio telescope, a powerful narrowband transmission at 1420.4 megahertz lasting 72 seconds. It was never detected again despite repeated searches. Loeb notes that 3I Atlas's trajectory appears to originate from approximately the same region of sky, within 9 degrees of the WOW signal source. He calculates that if 3I Atlas was positioned about 600 astronomical units from Earth in 1977, it could have produced the signal with 0.5 to 2 gigawatts of power. The scientific problems with this connection. 1. We don't know where the WOW signal actually came from. It could be light years away or much closer. 2. The signal was never repeated. 3. There are several natural explanations for transient radio signals. 4. Connecting a 1977 signal to a 2024 object requires multiple unprovable assumptions. 5. The 9-degree alignment could easily be coincidental, given the small sample size. Regarding the industrial nickel alloys language, Some have quietly discussed whether this could represent waste or byproducts from an artificial structure. However, there's no evidence supporting this beyond the chemical composition anomaly, which has a known natural explanation.
Across the past week or so. But in addition, yesterday, I decided to submit a white paper to the United Nations, basically calling for the creation of a committee that will analyze what we know about interstellar objects that come into the solar system from outside, similar to 3I Atlas, that look anomalous, because we have to be prepared for a black swan event, an event with a small probability that could change everything for us. And it's really important to be prepared for that. And currently there is no international organization. Obviously, alien technology would be a threat to all humans on Earth. It wouldn't care how we split the land on this rock that we call our home, the Earth. And so it's an international matter, and we need to be organized in that fashion. And I'm suggesting, given that the Rubin Observatory in Chile will find a new interstellar object every few months in the coming decade, that we attend to each of those through a committee that would look at all the data, use all the assets we have to evaluate the risk or the threat, how anomalous the object is, and then decide about how to respond to it if it looks suspicious.
What radio observations show? Interestingly, despite the WOW signal correlation claims, no radio telescope has been directed at 3I Atlas to search for potential transmissions. This would be an obvious test if there were genuine concern about artificial signals. So, where does all this leave us? Immediate future. Between now and when 3I Atlas passes behind the Sun from Earth's perspective, we should see official release of the Mars orbiter data. ESA's images from Mars Express and ExoMars TGO, and eventually NASA's HiRISE images once the government shutdown ends. These will provide actual size confirmation, surface feature resolution, if any exist, better spectroscopic composition data, tests of Loeb size estimates. October 29, 2025, 3I Atlas reaches closest approach to the Sun at 202 million kilometers. According to natural comet models, this is when we might see increased outgassing activity, possible fragmentation if it's an icy body, changes in brightness and tail structure. According to Loeb's hypothesis, this is when we might see maneuvering behavior, if artificial, release of probes, speculative, other non-natural activity. November 2nd to 25th, 2025. ESA's Jupiter Icy Moons Explorer, JUICE, will observe 3I Atlas with various instruments. The ESA states, as JUICE looks towards 3I Atlas so soon after its closest approach to the Sun, it is likely to have the best view of the comet in a very active state, with a bright halo around its nucleus and a long tail stretching out behind it. Then 3I Atlas leaves. After passing Jupiter, 3I Atlas exits our solar system. This is likely our only chance to study this particular visitor. The scientific bottom line. Here's what we can state with confidence. 3I Atlas is definitely from another star system, confirmed by orbital analysis. It has unusual characteristics, confirmed by spectroscopy and photometry. All observed behaviors have proposed natural explanations: metal carbonyls, compositional diversity. It poses zero danger to Earth, confirmed by orbital mechanics. We need more data. Mars orbiter observations pending. What remains speculative? Artificial origin. No evidence supports this WOW signal connection. Highly speculative leap. Whether properties are truly anomalous or just unusual examples of natural diversity. Why this matters? Regardless of whether 3I Atlas turns out to be a weird natural comet or something more exotic, each interstellar visitor teaches us about conditions, materials, and processes in other star systems. That's valuable scientific knowledge. The disagreement between Loeb and mainstream astronomers is actually healthy. Science needs people asking, what if we're missing something? And people applying rigorous skepticism. Both perspectives advance understanding. The Mars orbiter data, when released, will provide our best look at an interstellar object ever obtained. That data, not speculation, will move us closer to answers. Thank you for watching. I'll update you when the official Mars images are released. Subscribe for fact-based coverage as this story develops.